Okay, so today we're going to be talking about the volume of cylinders, cones, and spheres. And I want you to remember that volume is what can fit inside of an object. We've got a lot of measurements in geometry. Perimeter is distance around an object. Area is how much it takes to cover an object. And then volume is how much you can fit inside an object. So when we're talking about volume, we're talking about three-dimensional shapes. So let's get out our notes page and get ready to take notes on that. Okay, here are your volume notes, and let's fill this out as we go here. A couple key vocabulary terms that I want you to remember. We're going to be finding volume of circular objects, so remember that radius is the distance from the center point of a circle to the edge of the circle. Remember, it's 1/2 of the diameter. Diameter is the distance across the circle through the center point. In all the formulas that we use for volume of circular figures, radius is in the formula, but sometimes they'll give you the diameter, and you need to remember to take half of that diameter to be able to have the radius to use in the formula. The first thing you need to be able to do in order to find the volume of circular figures is identify those figures. And we need to be able to identify a cylinder, a cone, and a sphere. You've probably done this before. Remember that a cylinder has two circular bases. So some objects that might be a cylinder would be a paper towel roll, or a cup, or a pencil. It has two circular bases, one at the top and one at the bottom. A cone has one circular base. Obviously, the most common cone is an ice cream cone, or maybe an orange cone on the side of the road, or maybe that you might use in football practice or basketball practice. And then finally, a sphere is basically a ball. And in a sphere, all of the points are the same distance from the other points. So from the center to out to the edge, all of them are equally distant all the way around. So now that we've identified our shapes, then let's come over here and talk about how to calculate the volume of a cylinder, a cone, and a sphere. First thing, obviously, is we're going to have to know the formulas. Now, I won't make you memorize those. They'll be given to you, but you need to know how to be able to use those. The volume of a cylinder, its formula is pi times the radius squared times the height. Cone is 1/3 of a cylinder, so its formula is 1/3 times pi times the radius squared times the height. And the sphere is 4/3 times pi times the radius cubed. Notice it doesn't have height in it, so it needs 3 radius multiplied together. Obviously, a ball doesn't have height. So once you know the formulas, then the next thing you need to be able to do is you've got to identify what shape that is given to you in the problem. And then once you've got the shape, you want to choose the correct formula based on the shape. And then, just like in any equation, formulas are equations, you want to substitute the measurements that are given to you into the formula for the correct variable. And let's talk about some of those variables that you will see in these formulas. The V in the formula is volume. Pi is, remember, is an irrational number, goes on forever, but we can use the estimate of 3.14 for pi. You can use the pi button in your calculator. It will give you a longer decimal than 3.14 as an estimate. So either one is fine. Just make sure you read the problem. Sometimes they will ask you specifically to use 3.14. R stands for radius. Again, remember that that's half of the diameter. And H stands for the height of the object. So once we've substituted our measurements into the formula, then we can solve the equation for the unknown variable. So let's try a few of these problems. So here's our examples. We're going to find the volume of each shape and round our answer to the nearest tenth. In this first problem, we identify that this is a cylinder. So we need to make sure that we use the correct formula. And the formula for volume of a cylinder is pi times r squared times the height. So now we can substitute. We don't know the volume, and for pi I'm going to use 3.14. The radius is this distance halfway across the circle, so that's 10, and don't forget to square it. And the height is how tall the object is, so it's 18 millimeters. So we'll substitute that in place of the height. So if we go ahead and do 3.14 times 10 squared times 18, we'll get our volume. That turns out to be 5,652. Don't forget to put your measurements on that. It's millimeters, and it's cubed. Now the number's not cubed, but the measurement is cubed. That tells you that the object is three-dimensional, and volume will always have cubed on its measurement. If you kind of recall that area had squared on its measurement because we've multiplied two measurements together. Here we're multiplying three measurements, 2 radius and 1 height. Now turn over to the back side and let's do a couple more examples. Okay, if you look on the back page of your notes, you can see that we have a cone in this problem, and the formula for volume of a cone is 1/3 pi r squared times h. So we're going to use 3.14 for pi. Then the radius is 2 yards, so we're going to use 2 and then square it. And then the height is 4 yards, so we'll put 4 in place of the height. So when I multiply all of that together, I get 16.74 yards cubed. Remember, we want to round to the nearest tenth. One way you can do that is you can think on a number line, 16.74 would be between 16.70 and 16.80. So is 16.74 closer to 16.70 or 16.80? Well, it's a little bit closer to 16.70. So we would round this to 16.7. Now we could put the 0 on it, make it 70, but it means the same thing. So our volume of this cone is 16.7 yards cubed. Let's look at our next example. In the next example, we have a sphere. So we're going to use the formula for volume of a sphere. And it's 4/3 times pi times the radius cubed. In this problem, we know the radius is 5 meters. So we'll use 3.14 for pi and 5 for our radius. Don't forget to cube it. So we can multiply all of that together, and our volume turns out to be 523.33, repeating, meters cubed. Again, we want to round to the nearest tenth. So we want to ask ourselves, we know that 523.33 would be between 523.30 and 523.40. but it's closer to 523.30. So when we round this, this would be 523.3 meters cubed. Okay, let's go up here to the other side and take care of our third objective, which is to solve real-world problems involving the volume of a cylinder, a cone, and sphere. It's a good idea on any real-world problem or any word problem, if you can, to make a drawing. If they don't give you a drawing, make a drawing. Some of you are really good at that. And also make a plan to solve your problem. Label the measurements on your drawing. Then we can do what we've been doing and identify the shape and write the correct formula down. Then we can substitute our measurements into the formula and solve the equation. Now keep in mind on these word problems that there could be more than one step to find the answer. So let's take a look at this first example here. It says, what is the volume of the figure when a 10 millimeter diameter cylinder is removed? So we've got a big cylinder here that we filled up with something because it's asking about volume. So we have filled this cylinder up, and we're going to remove this little cylinder. Well, if I remove something, in math, that operation is subtraction. So it looks like in my plan I need to have subtraction in there. So my plan will be to find the volume of the big cylinder and remove or subtract the volume of the little cylinder. That's what I think I need to do. So let's see if we have the measurements to do that. Let's try to find the volume of the big cylinder first. Well, volume of any cylinder is pi times the radius squared times the height. So let's substitute our measurements now. For pi, I'm going to use 3.14. The radius is halfway across the circular base. Well, it doesn't tell us the radius, it tells us the diameter though. And remember, radius is half of the diameter, so I could divide that by 2, and I would get 18 millimeters for the radius of that big cylinder. So I'm going to square that. Then the height of the big cylinder is over here, it's 40 millimeters. So I'm going to multiply all that together, and when I multiply all of that together, I get 40,694.4 millimeters cubed. That's the volume of the big cylinder. Okay, now let's find the volume of our little cylinder. So the volume of our little cylinder is going to be the same formula as the volume of our big cylinder, pi times radius squared times the height. So we're going to use 3.14 in place of pi. Now let's see about the radius of our little cylinder. It doesn't look like on the drawing they give us that. 18 is not the radius of the little cylinder. So let's go back up and look in our problem, see if we can find that, any information about that. And they do tell us that a 10 millimeter diameter is the diameter of the little cylinder. So I know if I divide that by 2, that will give me 5 millimeters as the radius of my little cylinder. So I can substitute, in place of the radius, I can put 5 and square it. And then the height of the little cylinder is the same as the height of the big cylinder, so I'm going to substitute 40 in place of the height. So when I multiply all of that, I get 3,140 millimeters cubed for the volume of the little cylinder. Now remember, I'm going to be subtracting those volumes to find what's left. So 40,694.4 minus 3,140. And after I subtract those, then that's going to tell me the volume of what's remaining. So that turns out to be 37,554.4 millimeters cubed. Okay, so I'll be assigning some problems for you to practice tonight on volume of cylinders, spheres, and cones.